Now this is conic sections objective solved example question number 4. Now this is a given curve x cube plus y cube equal to 0. We have to tell the locus of this. We need to tell what like the curve represented by this equation. Basically, if I replace all the order pairs, if I just list down all the imaginary as well as real order pairs that satisfy this equation, then we need to comment on the curve, the trajectory on which they lie. So locus of all the points, imaginary as well as real, that satisfy this equation. So we'll factorize it, right? From this we get the real factor. So y equal to minus x is a line that satisfies this cubic equation, and this is another curve that satisfies this cubic equation. But if you look at this curve, you factorize it, like the factors, if you see this degree 2 equation is representing a pair of imaginary lines. Because if I see the discriminant of this, assuming it to be a quadratic in y square minus x into y plus x square equal to 0. So discriminant is x square minus 4x square, or straight away is negative, so means we cannot have real factors of this. So this represents imaginary lines, or we can say imaginary factors, complex factors, or simply we can just check the condition h square minus ab. In this case h square minus ab is less than 0, right? So imaginary lines. Or I suggest in this question you can do it like this straight away: y cube equal to minus x cube, and you know the factors, the cube roots of minus x cube. You take cube root of both the sides. This is the real cube root. Another two cube roots are complex cube roots. Y equals to minus is the real cube root. Y equals to minus x omega. Y equals to minus x omega square. So these are three lines. Out of them, this is real, this is imaginary, and this is also imaginary, right? So this equation represents three lines, out of which one real and two imaginary.